friends, today I am going to discuss about Fraunhofer diffraction due to two slits. This question may ask like this: the Fraunhofer diffraction due to two slits, or the Fraunhofer diffraction at two parallel slits, or Fraunhofer diffraction at double slit. We already discussed in Fraunhofer diffraction experiment. In that experiment, there would be one. In Fraunhofer single slit experiment, there is a single slit. That single slit consists of one wavefront. That wavefront contains number of secondary wavelets. The secondary wavelets are combined with each other. They form pattern on screen. The intensity will be in the decreasing order. But here in this experiment, there are two slits. These two slits represents two wavefronts. These two wavefronts consist of number of secondary wavelets. So the superposition of secondary wavelets, which belongs to the same wavefronts and different wavefronts also, they give a mixed pattern of diffraction and interference also. So in this experiment, what we have to do in single slit experiment, we have done everything. That means we splitted the slit into n equal parts, and we assumed that the secondary wavelets are n number of wavelets and etc. But here we have to superimpose the two secondary wavelets which belongs to the wavefronts, and here we have to find out the vector addition of the secondary in this we have to superimpose the two wavefronts by making vector addition. By vector addition, I have to make the two wavefronts the superposition. By vector addition means, already I told you in the interference, that is R is equal to root of a1 square plus a2 square plus 2a1 a2 cos delta, where delta is called the phase difference between two wavefronts. Like that, you know well that formula. I have to substitute this means single slit resultant in this AB, then we will be getting a diffraction pattern as well as interference pattern. It means a sine value and cos value also we will be getting. So by solving now, after getting this solution, we can find out the cases. I have to check the different cases, like the position of the principal maxima, positions of the minima, secondary maxima. But along with this, we have to find out the pattern of the interference. And when these two patterns are mixed together, what happens? Like so, we have to solve for every question. That is the approach is same. Like first of all, we have to find the path difference, then phase difference, then something like that. This is the first of all, we have to find path difference and corresponding phase difference. Okay, so let us start the session. Fraunhofer diffraction due to two parallel slits, or two slits or double slit. And let us assume this is a monochromatic light of a parallel beam. This is an opaque screen. On this screen, AB and CD represents two slits, or S1 and S2 represents two slits, and E plus D is called the distance between two slits. That means the midpoint of the first slit to midpoint of the second slit, that is called E plus D. The gap between two slits are D, then E by 2 gives the grating element, that is E plus D. In case of grating, in case of N slits, this can be called as a grating element. Now a monochromatic light enters from this slit. It gives it it contains one wavefront and CD gives one wavefront. Here we have to find the superposition of these two wavefronts. Each wavefront consists of number of secondary wavelets. So here the secondary wavelets enters into this slit which are parallel to this incident beam. They form image at P0 which are making an angle theta with the incident beam. This is the incident beam. This is making some angle theta. Then they form image at P1. Here we have to find the superposition of these two wavefronts. Here we will be getting a diffraction pattern as well as an interference pattern also. Here we have to get. Let us describe this. Let us the distance between. According to single slit, the resultant amplitude of each wavefront, already we discussed in previous class, is equal to a sine alpha by alpha, where alpha is equal to pi e sine theta by lambda. Pi e sine theta by lambda. We know this. Now here, come to this situation, I had to find out the path difference between two rays. This ray and this ray. The path difference will be around s to k. Here, path difference is equal to s2 into k. That is equal to e plus d sine theta. In case of single slit, the path difference is e sine theta, but here e plus d sine theta because of two slits. The corresponding phase difference delta is equal to 2 pi by lambda into path difference. 2 pi by lambda into path difference. Then delta is equal to 2 pi by lambda into e plus d sine theta. Yes, this is equation number 1, which represents the phase difference. This is the phase difference. This is the phase difference. Now, coming to this situation, if I close this slit, the pattern will be like a single slit. If I close this slit, this pattern also gives like a single slit. If two slits are open, then what happens? Here one wavefront is there. Already we know the amplitude of the wavefront. Here we have to consider a vector addition method to solve this equation. So let us suppose let a1 is equal to a sine alpha by alpha and a2 is equal to again a sine alpha by alpha. That means here the wavefront is small a1, here the wavefront is small a2, and the phase difference is phase difference is delta. Then by vector addition method, that means the superposition of these two wavefronts gives, then according to superposition theorem, capital R is equal to root over a1 square plus a2 square plus 2a1 a2 cos delta. This is the equation. Now we have to substitute these amplitudes, individual amplitudes of the waves in this equation. Then we get the combined effect of the two wave fronts. Now I substituted a value in this equation. Then by solve this equation, that is 2 into a sin alpha by alpha, 2 into a sin alpha by alpha whole square plus 2 into a sin alpha by alpha again whole square into cos delta root over r is equal to, then r is equal to 2 into a sin alpha by alpha square, take a common factor of this 1 plus cos delta, this is root. Now r is equal to 1 plus cos delta means 2 cos square delta square by 2. That means 2 into a sin alpha by alpha square into 2 cos square delta by 2. This is root. R is equal to 2 into 2 4 a sin alpha by alpha square cos square delta by 2. Then the resultant amplitude of two wavefronts will be r is equal to 2 a sin alpha by alpha then cos delta by 2, resultant amplitude of the two wavefronts. I have to examine this equation for further solving, where alpha is equal to pi e sin theta by lambda and delta is equal to 2 pi by lambda into e plus d sin theta. This equation came from single slit. This expression came from current question, Fraunhofer 2 slits. Now similarly, the intensity of two slits is I is equal to r square, we know. Then I is equal to 4 into a sin alpha by alpha whole square cos square delta by 2. So this gives the maximum intensity of the two slits, the resultant intensity of two slits. In the resultant equation, a square sin square alpha by alpha square derived from Fraunhofer single slit experiment, that is the intensity distribution due to any individual slit. If I consider a first slit or second slit, it gives this type of equation. Cos square delta by 2 gives the interference pattern due to waves starting from parallel slits. The intensity depends upon these two factors, that is, depends on this a sin alpha by alpha whole square. Finally, the intensity depends upon this equation. Now we have to check the case study. We have to check the different cases. Condition for central maximum. So condition for central maximum means R should be maximum. When R should be maximum means the denominator is equals to 0. That means the condition is let alpha is equal to 0 but sin alpha is not equals to 0. Then but here we know alpha is equal to pi e sin theta by lambda. When alpha is equal to 0, substitute in this equation, then pi e sin theta by lambda is equal to 0, then sin theta is equal to 0, then theta is equal to 0 degrees. It's 0 degrees. Condition for minimum, that is, again we have to take R is equal to a sin alpha by alpha. Here numerator is equal to 0, that is sin alpha is equal to 0 but alpha not equals to 0. That means this denominator alpha not equal to 0, where alpha is equal to pi e sin theta by lambda. Now substitute this value here. Alpha means sin alpha is equal to 0 means alpha is equal to plus or minus m pi according to this condition. Now substitute this value in this equation. It is pi e sin theta is equal to plus or minus m pi by lambda. Pi and pi gets cancelled, that is e sin theta is equal to m lambda. But here the where m means this m gives 1, 2, 3, 4 and so on. Here alpha is equal to pi, 2 pi, 3 pi, 4 pi. That means we will be getting at pi, 2 pi, 3 pi, 4 pi the dark fringe. Here central maxima at midpoint we will be getting a bright fringe, that is central maxima. Next the position of the secondary maxima. We know the principal maxima at 0 degrees and the minima at pi, 2 pi, 3 pi, 4. That means the secondary maxima exists in between two minima. So then the position will be alpha is equal to, already we solved in single slit experiment, that is 3 pi by 2 and plus or minus 5 pi by 2 plus or minus 7 pi by 2, because here pi by 2 won't come because this pi by 2 is mixed with central maxima. So after central maxima only it gives different secondary maxima intensities. Here now take the term of cos square delta by 2. So this represents equidistant dark and bright fringes, interference fringes it represents. So let us to minimize the confusion, let us substitute beta at the position of delta, then cos square beta becomes 1. Then if cos maxima when n pi when beta is equals to n pi, the cos term will be at maxima, where n is equal to 0, 1, 2, 3, 4 up to n values. Now the minima at cos square beta is equal to 0. When beta becomes 0, the value will be minima. Cos square beta is equal to 0, that gives minimum. Then delta is equal to 2n plus 1 into pi by 2 is equal to, that means beta is equal to 2n plus 1 into pi by 2, where n is equal to 0, 1, 2, 3 up to n. This is the condition. Here for bridesmaids, this cos term equals to 1. This is maxima, this is minima value. Now n lambda 1, 2, 3, 4 lambda 1, 2, 3, 4 pi gives the bright fringe. Here half, 1 and half, 2 and half, 3 and half gives a dark fringe. If we observe this diagram, this intensity in decreasing order gives the, according to the interference single slit. This pattern represents the interference pattern, so which is the combination of two slits. By mixing these two designs, these two patterns, we will be getting this pattern. That means the interference pattern exists in the diffraction pattern. This gives the resultant intensity of the two slits.